Hello and welcome back to Math with Lou. Today we are going to be talking about composing expressions. So composing expressions essentially means that we are given a real world scenario and we need to map it mathematically using mathematical language and syntax. So as you can see, I have a list of verbal phrases that translate to operators, and we're going to run through these really quickly. These are key words you're going to see in your word problems that are essentially going to tell you which operator we're going to need to use. Sum of, total of, plus, increased by, gain, raise, or more. Those translate to using addition. Difference between, minus, decreased by, loss, less, fewer, take away. These are all words that translate to subtraction. Multiply, product of, times, twice, times 2, triple, times 3, percent of, or fraction. This translates to multiplication. And then quotient of, divide, divided by, divided equally, or per. This translates to division. I made a little note here, percent of. This might look a little confusing, so I want to explain this. As we should have learned from earlier levels of math, when we translate percentages into math grammar, we express it as a decimal. So 5% would become 0.05. So if it says multiply something by 5%, what you're really doing is multiplying it by this number here, which is kind of why I wrote it, how I did over here. I hope if this confuses you, just ignore this. But again, I was just trying to illustrate that percent of we go from a percentage number to a decimal here. And likewise, another quick example, if we see, 200%, this would translate to simply 2.00 or 2. Okay, let's get rid of this and let's take a look at our first problem below. So in this problem here, I'm going to walk you through the steps on how we can express this mathematically. So this problem reads, Joe is at a car rental service to rent a car. There is an administration fee of $35 plus an additional $15 each day Joe has the car. Write an expression for the total cost of renting a car. So the first thing we need to focus in on is we need to highlight the key information from this problem. And this includes our administration fee of $35 and our additional $15 for each day. For each is synonymous with per, which tells us this is going to be multiplication. We're going to multiply 15 by each day. And because I wrote here we have an additional $15 per each day, this is going to be added to the 35. So we'll get to that down below. But again, I just wanted to go over the key information from this problem. Step 2, we're going to define our variables. All of these expressions are going to have unknown variables. And in this problem, our unknown variable is the days. That's going to be our x here. So next we are going to write it as a verbal model. We're going to translate this model using plain English, and we're going to translate it to math. But first, let's see how this would look in just plain English. When you're renting the car, you have to pay the administration fee plus whatever the daily price is times the number of days. And that's exactly what the problem says here. The administration fee plus $15 times number of days. And lastly, we translate this to a mathematical model. The administration fee is $35 plus the daily price of 15 times our unknown number of days. And this would be the mathematical model for the given problem. All right, so I have one more example over here. This one's a little bit different. This one's not going to have an unknown variable, but this is a good everyday problem that I want to talk about. So let's read this one here. This one reads, Bob drives 500 miles in 300 minutes. Find Bob's average rate of change in miles per hour. Okay, so the key information here, I'm not going to write it out for the sake of time, but the key information here is 500 miles in 300 minutes, and we need to find the rate of change in miles per hour. So we're looking for a rate here. And the first problem I see is we are given that he drives 500 miles in 300 minutes, but we need hours. So first we need to find out how many hours 300 minutes is. So let's do that. So we have 300 minutes And we are going to figure this out by dividing our 300 minutes by the amount of minutes in an hour. Or, how they taught it to me when I was taking high school physics is we make a fraction out of this and we multiply this by the ratio of hours to minutes. So there is 1 hour in 60 minutes. And what's nice about writing this out this way, what I really like about this is, notice here we have minutes in the numerator, minutes in the denominator. We can treat our units of time just like variables, and we will see that these will cancel out, and the only thing we're left with is the hour up here. And we can also simplify this here. 300 over 60 is the same thing as 30 over 6, which is simply going to become 5. This becomes a 1, this becomes a 5. So we have just found that 300 minutes is equal to 5 hours. Okay, so next we're going to express the how many miles Bob drew as a ratio of miles to hours. Miles per hour here tells us, if we look up ahead, per to, same thing, we're going to divide. So we're going to write this as 500 miles per 5 hours. And we can see here that this fraction can also be simplified. We can factor a 5 out of both terms. We factor a 5 out of this, we get 100. We factor a 5 out of this, we get 1. And we find that Bob was driving incredibly fast at a rate of 100 miles per hour. Please do not drive that fast. That is way, way above the speed limits in almost every place except for that big road in Germany. I can't remember the name, whatever. But anywho, this covers this section. As always, I'm going to put the notes for this video in the description. And thank you for watching. Hope to see you next time.